ಐತಿ ಕನೆಕ್ಟಿವಿಟಿ ಐತಿ ಕನೆಕ್ಟಿವಿಟಿ ಐತಪ್ಪ ಅಂತ ಪ್ರೇಮ್ಕುಮಾರ್ ಐತಿ ಈಗ
Good morning, sir.
Good morning, Premkumar. Like two times, Mahadevi joined. ಎಷ್ಟು ಮಂದಿ ಇದ್ರಲ್ಲಿ 3 members.
Mahadevi, irumala, next Veena Patil.
Irumala. Okay. Irumala joined. Premkumar.
Yes, sir. Good morning.
Yes, sir. Good morning, sir.
Good morning, sir.
Good morning, sir.
Who is that in training videos? Okay.
Sir, me, sir. Veena Patil, sir.
Okay. Who is having laptop with you right now?
Sir, I am having.
I
Okay.
do have.
Okay, then no problem. Not an issue. So we're going to be present right now. Click on the present now and
Yes, sir.
share your PPT. Okay.
Yes, sir.
Yes, sir.
The moment when I say yes, then only you have to start the presentation. And meanwhile, while presenting, what you can do, please turn off your microphones and video. Okay. The moment when your turn is there, then only you have to unmute your mic and you have to speak. See, I'm getting echo right now. Whatever I'm speaking, just is getting the replica of the same. Veena is presenting or Mahadev is presenting?
Sir,
Me,
Mahadevi
Veena
is
Patil, sir.
presenting.
Okay, okay.
PPT I will present, sir.
Okay. Make a slideshow, Veena.
Slideshow.
Yes, sir.
Yes. Okay. Just a minute. Recording is started. Okay. Smart device for visually impaired people using Raspberry Pi. Okay. Go ahead.
Good morning, sir. Myself, MahadeviS Bhohite from HM Electronics and Communication Department. With my teammates, N Kulakarni, Veena Patil, and Premkumar Kadatti. Our project title is Smart Assistive Device for Visually Impaired People using Raspberry Pi, carried out under the guidance of Professor D D Billur, sir. Coming to the contents of the project, introduction, objectives, block diagram, software and hardware requirements, pin diagram, results, applications, advantages and disadvantages, conclusion, and references. Coming to introduction of the project, vision is the most important part of human physiology, as 83% of the information human beings get from sight. According to WHO, there are 285 million people in the world with visual impairment, 39 billion are blind, and 246 million with low vision. The oldest aid for the blind persons are walking canine guide dogs. Now, due to the advancement in technology in both software and hardware, we have developed a lot of electronic travel aids which helps the blind people. Our objective of the project is to implement the smart spec, which helps the blind people to provide real-time navigation for the blind person, converting captured image to speech with accuracy, obstacle detection that comes in the path of blind person. This is the overall block diagram of our project. We have used Raspberry Pi 4, which is the main component of our project, to which all the devices we have interfaced. It is the latest SBC from Raspberry Pi Foundation, with updated processor, USB 3.0, dual 4K display
Madhavi,
support.
click on that. Madhavi, one pop-up window is there. Click on that hide button.
Sir,
Stop sharing and hide option is there, no?
Yes, sir.
Click on that pop-up window. Hide on the hide button.
Wait, sir. Okay, sir.
On hide. Okay. Now slideshow. Yes. Go ahead.
okay. It has dual 4K display support and 40 KB RAM and updated gigabit Ethernet chip. It is a 64-bit quad-core processor which is running at 1.4 gigahertz. It has 3 USB ports and wireless LAN dual band which is of 2.4 gigahertz and 5 gigahertz. It has faster Ethernet. It has a processor called Broadcom DCM2711. Its memory is 1 GB, 2 GB or 4 GB. It is a 40-pin GPIO header. It uses 5-volt DC supply which is connected via the USB-C connection. Coming to the push button. Block diagram. Okay. Coming to push button. Push button, it is used to switch between the modes in our project. In our project, we have 3 modes: navigation mode, board reading mode, and obstacle detection mode. To switch between these modes, we are using the push button. Its one end is connected to the Raspberry Pi pin 16, that is GPIO 3, and other is connected to ground. We are using uBlox Neo 6N GPS modem for the navigation assistant. It is a I2C complaint GPS module. It works with 5-volt input. It is connected to the 10th pin on the Raspberry Pi board. It has 4 pins: VCC, ground, transmitter, and receiver. VCC is connected to 5-volt supply. Ground is connected to ground pin of Raspberry Pi. Transmitter is connected to receiver of Raspberry Pi, and receiver is connected to transmitter of Raspberry Pi. And we are using HC SR04 sensor to measure the distance of obstacle of the blind person. It transmits the ultrasonic waves into the air and detect the reflected waves from the object. HC SR04, it is rated at 5 volt. However, input Raspberry Pi GPIO is rated at 3.3 volt. It can range the distance up to 2 centimeter to 400 centimeter. This sensor consists of 3 parts: ultrasonic transmitter, control circuit, and the ultrasonic receiver. Ultrasonic sensor, it generates the ultrasonic sound at 40 kilohertz, and ultrasonic receiver will receive the signal back from the transmitter. It has 4 pins, namely the VCC, trigger, echo, and ground. VCC is connected to VCC of the Raspberry Pi, and ground is connected to ground pin. Trigger is connected to pin 16, that is GPIO 23, and echo is connected to pin 18, that is GPIO 24. We have developed a ML-based model which is capable of developing different types of objects in the path of blind person using camera which is mounted on the system. To implement the image processing techniques, we are using OpenCV to detect the region of interest. We have used the microphone to take the voice feedback from the blind person, and it is and the device to do the preferred location. Speaker is given as an audio output so that blind person can hear from the device. These are the hardware requirements. We have used Python for the programming of the we have Python for programming. The next part will be continued by Veena.
This is the pin diagram of our project. This is the overall model of our project. Our one of the objective is obstacle detection. In obstacle detection, we used ultrasonic sensors and Raspberry Pi, which is interfaced through the ESP8266 Node MCU Wi-Fi module. We can interface ultrasonic sensors directly to the Raspberry Pi GPIO pin, but there is unnecessary delay happen in the output due to the lot of works processes working in the Raspberry Pi. For that, to reduce that delay, we are interfacing ESP8266 node MCU. The ultrasonic sensors, it takes, if any obstacle is come in the path of the blind persons, it will take the signal from the reflected signal, and it will send that into the ESP8266 node MCU, ESP8266 mode MCU convert that signals into the digital signals to the Raspberry Pi. Then Raspberry Pi will give a wise output to the blind persons. In the working principle of ultrasonic sensor is we are sending the signals from the transmitter, and if any obstacle comes in the path of the blind person, it will hit the object and it comes to the receiver part of the transducer of the ultrasonic sensors. And in ultrasonic sensors there are 4 pins: VCC, echo, then ground, and trigger pin. We are sending input to the trigger pin. Initially we are making the trigger as low, and then we are making trigger as high. When we are making trigger pin as high, we are sending the data into the data, and if any obstacle comes, it will hit back to the receiver. In receiver we are using echo pin. Initially echo pin is low, and when echo pin is high, we are starting the counter, and when echo pin is getting high, we are updating the counter. And we also using a time function which will returns the epoch time. By using these functions, for it will give the continuous stream of seconds from traveling from one point to another point. This is the output of our obstacle detection. Next we'll continue, Tirumala.
Hello, Veena. Can you please stop the presentation so that I can present?
Okay.
Hello, sir. Whether the model is visible?
Thirumal, first what you can do, you have to complete all presentations.
Yeah, sir.
At the end, you can give the demo.
Okay, sir.
I would
No
like
problem.
the demo at the end. Meanwhile, please complete all the
Yes.
presentation.
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Please go ahead.
Veena, can you please share the presentation?
Ha.
PPT presentation. You directly go to the advantages.
I am Premkumar. Advantages of project.
Premkumar, just a minute. What is the previous slide, Veena? Just go back.
Obstacle detections.
10th slide. 9th.
This will explain, Tirumala sir.
Okay. 9th. Okay. 10th.
10th I already explained, sir.
Okay. 11.
This will.
Premkumar, go ahead.
Advantages. The proposed project can be used to assist the blind people to understand the proximity and type of obstacles in their path. The project can help blind people navigate freely using voice-based assistance. The project can also help blind people to use audio commands to get navigation assistance using speech recognition, thereby making them completely independent. The project can also help them read messages on boards using OCR. The device helps the visually impaired people and makes them to feel independent. Disadvantages. Due to integration of several chips and sensors, the device size will be large. In real-time system, it is difficult to process the image with complex background. Sometimes the user may not get proper assistance from device in some situations like heavy train, traffic, and foggy weather. Applications. It helps to understand various languages for visually impaired people. It helps in navigation. It helps in object detection and prevents accidental injury. It helps to prevent impairments and secondary health conditions. It acts as learning aid and helps the people to track the global information. Conclusion: the system enables the visually impaired not to feel disadvantaged when it comes to reading text in Braille, traveling. We have implemented an image to speech conversion technique using Raspberry Pi. This is an economical and efficient device for visually impaired people and useful to society. This portable device can be used independently by people. Reference. Thank you.
Sir, can I?
Okay, now the demo. Give the demo now.
Hello, sir.
Ah,
Sir, I'm not explaining about camera. Can I explain, sir?
yeah, no. Just give the demo and then we'll ask the questions. Hmm. About the faculty member.
Hello, sir.
Go ahead, go ahead.
Is it visible,
I'm
sir?
listening. Ah,
Yes, it's
okay. Ah.
Yes, sir. We
Yeah.
have three objectives in our project. First one is navigation assistance mode, and second one is obstacle detection mode, and third one is text to speech conversion. To achieve all three objectives, we have used three switches to shift between all three modes, sir. First one is navigation assistance mode, sir. Second one is object detection and classification. Third one is text to speech conversion. We are using push button for the text to speech conversion. Whenever we are going to press this button, the camera will capture the text from the images and it will convert to the respective speech, sir. And we have Raspberry Pi 4 module for the high processing, heavy processing, and we have one audio card to output the voice. And we have used one Node MCU because it was possible to directly interface the ultrasonic sensor to the Raspberry Pi. But when we did the same thing, we got unnecessary delay in the obstacle detection, sir. So that we have used a Node MCU and we connected the ultrasonic sensor through the Node MCU to the Raspberry Pi trigger pin, sir. And we are using one GPS modem, Neo 6M U blocks GPS modem for the navigation, and we are using one camera to detect and capture the images, sir. This is the camera we have used. Directly, I will go to the first objective, sir. Sir, shall I show you code?
Yes. Go ahead, go ahead.
Yes, sir.
See, code explanation is not necessary. Directly give me the
Yes, sir.
demo.
I will directly run the code and I will give the demo, sir.
Yes.
Yes, sir. So this is the code we have used. When I'm going to turn on this switch, it will going to turn on the navigation assistance mode. And we have used one speaker for the output now. When I turn on the switch, it will automated voice will say voice assistance mode is turned on. And using this microphone, user can input the destination place, sir. And what the system is going to do is it is going to fetch the destination longitude and latitude address, and it is going to enroute the route for the destination. When I turn on the switch, it will say like the user needs to give the input like direction. 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 Library. So automated voice will after user say direction, automated voice will ask for the destination input. Whenever the user gives the destination like bus stand, library, or some places, it will going to fetch the destination. It will going to fetch the destination address, and it will going to assist the blind person to the destination through the longitude and latitude. What we have done is we have placed some waypoints between current location and destination, which were placed between equal distances, so that when the person will move to the first waypoint, it will guide the person to the next waypoint until he reaches the destination. When the person will reach the destination, it will announce a message like your destination has been reached. And right now the GPS is available, so it is saying the direction for the library. And if the GPS is not available, then the message like GPS not available will be announced. And I'm going to shift between going to explain the second objective of the output, second objective of the project, that is object detection and classification. When I'm going to turn on this switch, it will going to turn on the object detection mode. So this is the spec we have used. The ultrasonic sensor and camera is mounted on the specs, so that obstacle can be detected. When I turn on this switch, it's a obstacle detection, because my hands are in front of the ultrasonic sensor, so it is interrupted and it is saying like obstacle is detected. And we are going to classify the what type of obstacle is present by using some OpenCV libraries like HAR cascade algorithm, which is going to classify the object which comes in the path of the blind person. So unfortunately, yesterday our camera has been damaged, sir. You can see the screen, sir. Hello, sir. Hello, sir.
Please continue. We are listening.
Yeah, sir. And this is the second objective of the our project. And third objective is text to speech conversion, sir. Whenever we are going to press this switch, whatever the text present on the image is going to be extracted from the complex background or simple background, and it is going to convert to the speech, and it is going to give the speech input through the microphone which we have connected. Currently, the camera is damaged, so that I can't show the output of text to speech conversion, sir. I have pre-recorded video. If you permit me, then we can show the pre-recorded output video, sir, which we take.
No. Further questions I'll take it, but right now the free recorded video is not necessary for me. Okay.
Yes, sir. Yes, sir.
Yeah. Is it over? Demonstration is over?
Yes, sir. All the three objectives are over.
Okay. So now my question is,
Yes, sir.
so just go to the code section and
Yes,
tell me how that your Node MCU and Raspberry Pi is connected. That section I would like to see.
Raspberry Pi and Node MCU, sir.
Node MCU.
Can I show the video, sir?
Yeah, no. Just in the code part, just show me it.
Code part.
Yeah, in the code part.
Yes.
Hmm.
Detection. Hello, sir.
Okay. Huh. Explain now.
I have to explain the code, sir.
Only just the interfacing part between Raspberry Pi and your Node MCU.
Raspberry Pi and Node MCU interfacing, sir.
Yes.
Sir, we are connecting the ultrasonic sensor. Ultrasonic sensor has 4 pins, sir. We are going to connect 4 pins to the Raspberry Pi only, sir. But trigger pin we are connecting to Node MCU, and from Node MCU we are going to trigger the Raspberry Pi input by connecting the cables, sir.
Hmm.
Yes, sir.
No. Just in the code part, whatever you did that, please explain. Just only the Raspberry Pi part and this one, Node MCU
MCU.
part. Not detail all the entire thing. Only this section I want to know. How these two going to be communicate each other? If you explain
Yes,
this much, it's sufficient for me. Only Raspberry Pi and this one, Node MCU.
Node MCU.
How they are going to communicate each other. Meanwhile, I am going to ask questions to others.
Yes, sir.
Veena, Mahadevi, and Premkumar. Tirumala, please search about that part. And other
Yes, sir.
people, my question is just check your block diagram. Everyone already people is with you. Just check it your block diagrams. In that, go to ultrasonic sensor part. Others, except Tirumala, others.
Yes, sir.
Just check the block diagram. What is shown in that block diagram? Can you say Veena or Prem Kumar? I want to ask the questions to Prem Kumar now. Prem Kumar, PPT is with you.
Yes, sir.
In the PPT, check that. Don't show to me. Just check
Yes,
yourself, Prem Kumar. Yeah, tell
Yes.
me how that Raspberry Pi is interface along with that this one ultrasonic sensor. In between, what the component is used according to your block diagram, not according to your uh, demo. Just check the block diagram and say
Ultrasonic, sir. Trigger pin is
ultrasonic
connected.
sensor. No. Just I'm saying that block diagram. In the block diagram, ultrasonic sensor is connected to which device according to your block diagram.
Yes, sir.
Hmm. Which Arduino board is used in between? Huh?
Raspberry Pi, sir.
Yeah, between Raspberry Pi and Arduino sensor. Sorry, ultrasonic sensor. Which Arduino board is used according to your block diagram?
With the Atmega, sir.
At Mega.
328P.
At Mega 32P. But here you're showing that node sensor. Is it right? Or what are the features may you attract that about node MCU compared to Atmega 382P? Even you can use for the reduction of this one if you are not using any this one Wi-Fi features. Only Arduino Nano is sufficient for that, no?
Yes, sir.
Isn't it? Prem Kumar.
Yes, sir.
Yeah. In the block diagram, the way of explanation is different and the implementation part is different. Why it's so? What is the reason? The node MCU is attracted rather than that at Mega. Prem Kumar, explain about it.
Sir.
If you don't know, tell me then. I'm going to ask to others also.
Don't know, sir.
Do you know Prem Kumar? Don't know. Okay. Mahadevi.
Yes, sir.
Same questions over to you.
Sir, We have used in block diagram we have put wrong, sir, that at mega. We were supposed to remove that, sir, but we didn't it.
Sorry.
Actually, we were supposed to remove that at mega, sir, and we have to replace that with node MCU, but we didn't it, sir.
Why?
Forgot to, sir.
Now you're giving final demo. The way of presentations and the way of the kit is developed is totally different. No. Veena.
Yes, sir.
What are the features are more attracted towards node MCU rather than Atmega 382P, 328P?
Sir, by using this that ESP8266, sir, that Raspberry Pi GPIO pin, it requires 3.3 volts, sir. By connecting the two resistance in parallel, we are converting that 5 volt into the 3.3 volts, sir. Because ultrasonic sensors, they require 5 voltage, sir.
See, even though you can use Arduino Nano also, no, because it's more cheaper than that, and what are the features are available in Node MCU? That's also available in the Arduino Nano also. Are you using any Wi-Fi devices from that Node MCU? Wi-Fi? It's
From
a Wi-Fi
remote,
device, no?
sir, only we are using the ports of D0 to D3. That pins we are using from ESP82.
But you are not using the features of this one, isn't it? Wi-Fi
No,
features are not using. Then
no,
the cost of your project is going to be reduced, drastically, na? 200 to 300 rupees, not so, not less amount.
yes, sir.
Okay. Premkumar,
Sir,
tell me how this text voice, the voice to text conversions is converted. What are the hardware components used for that? Text to voice. The
by
way
camera,
to
sir.
be text to voice. Okay.
The camera will detect, sir.
Huh.
The text is detected by the camera, sir.
Uh,
And by OCR technology, it will give the output, sir.
hmm. Please continue. I'm listening. I'm hearing
By,
you.
by
Huh.
camera will detect the text, sir.
Huh.
And by the OCR technique, the text is converted into speech, sir.
Okay. Hardware part I'm asking only hardware. Mahadevi.
Detectors, sir.
Time is over. Now the question is over to Mahadevi.
Sir, camera will detect the text, sir.
Hmm.
And by using the OCR technology, it will convert. It uses certain image technique processor, image
Okay,
process
fine.
techniques.
I would
Uh,
like to know the hardware components only. OCR is fine. It is going to be processed in that Raspberry Pi. Fine. Next.
so ML model, sir.
What ML model?
That machine learning model.
Okay, done. Next.
That machine learning, it is used to detect the text, sir.
Is it software
Uh,
part or hardware part? ML.
so software.
Okay, done. Next.
Yeah, this one.
Veena.
So we are using any camera, or we can use that Raspberry Pi camera, sir.
Okay.
When we are detecting any text, it should be of we are certain distance, sir. Up to that, distance, it can detect the text. And we are using OCR technology, and by using this, before that we are dumping a Python program into it.
No. So all those things are done. Fine. Up to Raspberry Pi is done. Okay. OSR, OCR, everything is there in the after Raspberry Pi. What are the components are used to convert this camera
Cam-
camera to Raspberry Pi to
Only Raspberry Pi, sir.
ಅಲ್ಲಮ್ಮ ರಾಸ್ಬೆರಿ ಪೈಗೆ ಒಂದು ಸ್ಪೀಕರ್ ಕನೆಕ್ಟ್ ಮಾಡಕ್ ಬೇಡ to get the text.
Sir, we are
Yes, sir.
connected speakers,
Huh?
sir. We
Speaker
are
is also
connected.
speaker. It's common, sir.
A speaker is not available, inbuilt not available, no. But
Sir, we are using audio card, sir.
audio
For Raspberry Pi, we are putting audio card, sir, for taking input from the blind person, sir, and we are using speakers for the audio output, sir.
okay. Prem Kumar,
Sir,
how much power supply is needed for entire kit? The various powers, various voltage level you can say.
5 volts, sir.
5 volts for
5 volts for Raspberry Pi, sir,
uh,
and 5 volts for GPS,
okay.
and 5 volt for ultrasonic sensor, sir.
Okay. What about node MCU?
5 volts, sir.
How you converted 230 volt to 5 volt here?
Power bank, sir. We have used power bank, sir.
Power bank, huh?
Yes, sir.
Once power bank is get discharged, how are you going to charge it?
Chargeable battery, sir. Cable, mobile charge.
Mobile charger you're using.
Yes, sir.
Very good, very good. Tirumala, have you searched that? No.
Yes, sir, I got.
Show me then.
So is it visible? Code part?
Yes, it's visible.
Yeah, sir. This is the obstacle detection part, sir, for sonar sensor. What we are doing is only trigger pin is connected from node MCU to the Raspberry Pi, sir. All other pins of the ultrasonic sensor are directly connected to the Raspberry Pi only, sir. Why we did this is because we are facing unnecessary delay, sir. As you said that our project cost can be reduced if we remove out the node MCU, but we will get the output delay, sir. Delayed output. That's why we used node MCU, and only one pin of the node MCU is directly trigger of the node MCU is directly connected to one GPIO pin of the Raspberry Pi. Here it is, sir. GPIO dot input assist button. If ARED is equal to 1, if trigger pin is high, sir, then it is going to detect the obstacle from the path, sir. If any obstacle is detected, then trigger pin will be made high, sir. Otherwise, it will be in sonar state. Will be in low state.
Okay.
Yes, sir.
Fine.
And we have used some OpenCV libraries to detect and classify the objectives, sir. As you can see, sir, we have used some classes like person, bicycle, car, motorcycle. We have used HAR algorithm, which is going to detect the shape, color, and various attributes of the objects, and it can classify the object depends on the its object shape and all the things, sir.
Okay.
Yes.
Fine. When you come to the college, you have to submit your hardware project as well as the report. Okay.
Yes, sir.
Sir, report hard copy we have to submit, sir.
Yeah, hard copy compulsory is required, no?
Yes, sir.
So how many
So
copy of
it is totally 4. 6. Total 6. 4 plus 2. And plus KSST1. Total 7.
yes, sir.
Yes, sir.
The individual copy must have only one single name.
4 individual, 3 all names.
Okay. 4 plus 3. 4 means it's individual. Okay. And plus.
Yes, sir.
Okay.
Total 7 copies we have to submit to the college, sir.
Yes. Along with that, your enter hardware model.
Yes.
Yes.
Okay.
Okay. Fine.
Thank
You may
you.
leave that meeting now.
Thank you,
Yes,
sir.
thank you.
Yes.
Thank you, sir.
Okay. Okay.